In a three-dimensional model space, we need to be able to define an object's location in reference to some other known place. To serve this purpose, model spaces have an origin point, which is a fixed location in space. The origin is so called because it is the origin point for the x, y, and z axes. At the origin point, the values of all the axes are 0. To describe an object's position in space, we can define the offset from the origin for each axis. If we define x at 5 foot, y at 2 foot, and z at 4 foot, the object goes to that position in space. Each of these offsets can be negative as well, getting the object on the other side of the origin. In a typical proscenium theater, your x-axis might describe your stage left, stage right movement, your y-axis might describe your upstage and downstage movement, and your z-axis is going to describe your height above or below the floor. Spatial position isn't the only important information about an object. We also want to know its rotation along each axis. That means that there are a total of 6 pieces of information that define the position and orientation of an object in space. This collection of data is often referred to as an object's pose information. All objects have a base point, which is where on the object the position and rotation values are referenced to. Many drafting programs allow you to define an object's base point. Now that we are comfortable with the principles of a 3D environment, let's see how we can use them in Augmented.